So this session I'm going to explain message ordering in distributed computation. So in that message ordering is nothing but the order of message will be delivered to the process. And that distributed computation means already know it's nothing but n number of interconnected network, different network computers. That means each and every computer want to communicate with the help of passing the messages. These messages must be in some order. That's called as a message ordering. So in there, message ordering means we have message will be transferred to the requested process based on the ordering. So in that in distributed systems, message delivery should be always predicted. So order of delivering the messages to the intended recipients. So message order is based on non-FIFO and then FIFO as a casual order and a synchronous order. In the non-FIFO order means that means it's not support the FIFO order. The message is delivered based on the random order. That means the receiver receives the messages based on random order. And then FIFO is nothing but first in, first out order. The message will be delivered based on the first in, first out order based on the message queue. Next one is the casual order. So casual order is nothing but if two events occur in the same process, the order of occurrence will be in based on the message ordering. That's M1 and M2 means M2 deliver the message after M1. M1 deliver the messages before M2. That's our casual ordering. So synchronous ordering means nothing but the message ordering is based on synchronous. Each and every time it send the messages and receive the acknowledgement based on the each and every message passing, message ordering, message passing techniques. So in that we have first one we have notations, and then what are the notations used in the company message ordering? First one network n comma l. N comma l is the n comma l network. Network and the L is nothing but locations. Here E1 set E and then less than capital E is nothing but a set of events, and then less than is nothing but a cash flow ordering events, and then message MI is nothing but a message send and receive events based on send event SI and receive events RI. Send and receive events S and R. Here M send of M and receive of M are the messages, and then corresponding events. B denotes the A and B occurred at the same process. The send the receive pairs that means T equal to S comma R belongs to EA into EJ. S corresponds to then send event is correspond to receive events. And asynchronous and FIFO execution. The asynchronous FIFO execution is based on see the diagram. Asynchronous execution, that is FIFO order, and the FIFO asynchronous execution in that S1, S2, S3. Here P1, P2 is a two process. R1, R2, R3 is a two. There's a three events. S1 is a send events. R is a receive events. So here we have a first exam diagram. Asynchronous execution, that is FIFO asynchronous execution. Yes, FIFO asynchronous execution. That means the message will be delivered based on the first in, first out order. That means asynchronous execution order is nothing but first in, first out order. So in that execution capital E and then less than for each casual relation is partial ordering. So no casualty cycles among the process, and then no on any logical link, not necessarily FIFO delivery. So network layers IPv4 connection service. It also support the first order. And also all physical links obey the FIFO order. In that execution that is not FIFO executions, and execution in which for all S comma R and S dash comma R belongs to T, then S tends to S dash and then R approximately R dash and S less than S dash and tends to R less than R dash. So that's R causal dependency on R dash and S causal dependency on S dash, and then logical link inherently non-FIFO. In the logical link is something but inherently non-FIFO. Can assume connection oriented services at transport layer TCP transmission protocol can assume the connection oriented services in the transport layer, and then to implement FIFO over non-FIFO link, so use sequence number and then connection ID for messages. The receiver use the purport to order the messages. That means each and every link the use sequence number comma connection ID, sequence number comma connection ID. So in the casual order definitions, casual order is something but say casual order execution is an asynchronous execution in which for all send and receive events and send and receive stress and r dash belongs to D, R approximately r dash and S approximately S less than S dash, then causal difference on S dash, that means R causal difference on R dash. If send event S and S dash are related by causality orderings, not physical time ordering, their corresponding receive events R and R dash occur in the same order to at all common tests. If S and S tests are not related by causality, then CO is case satisfied. And then see the diagrams. In the diagram, we have P1, P2, P3 process. The first one, it violates the causal order. Here we have so P1 in the P1 process have two receive events of the same process. The order of message is not in order, so it's called as it violates the causal ordering. Like that also, P satisfies the causality. Here we have there's a two event occurred the same process in the P2 process. First M2 and then M3 will be received. So it satisfies the causal ordering. And then third diagram satisfies the causal order and the no send events related by causality. And also for fourth event at satisfies the causal ordering techniques. That means in the P1 process, two events occurred in the same process. So one is M1 and M3 messages. M2, M1 is followed based on the M3. That's a satisfies the causal ordering messages. So another one is alternate definitions of causal ordering is nothing but if send of M1, the causal difference on send of M2, then the each common destination of T of messages M1 and M2 delivered M1 less than deliver M2 must be satisfied. So causal arrival versus delivery. The message M that arrives in OS buffer at PI may have to be delayed until the messages that were sent to the PI casually before M was sent. The overtaken messages have arrived. The event of an application processing and arrived messages is referred to the delivery events. So no message overtaken by a chain of messages between the same pair, that is send and receiver. And also already we have discussed the example M1 overtaken by chain M2 comma M2 comma M3. So code CO degenerates to FIFO when M1 and M2 sent by the same process. Here M1 M2 are the same process means first M1 will be delivered, after that M2 will be delivered. That's called as a causal ordering definitions. So and then message order MIMO. The message order is something but the order of message is based on send and receive events. Execution in which for all send and receive events S dash and R dash belongs to T. S causal difference on S dash and R causal difference on R dash. So here see the example. This is external example of causal ordering. M cannot be overtaken by chains. M is a message cannot be overtaken. It's called as a message order. And then empty interval property. So empty interval property is nothing but capital E and then causal order is an empty interval execution. If for each send and receive belongs to T, the open interval set X belongs to capital E and then S causal difference on X causal difference on R in the partial ordering is empty. Here partial order is empty, and then consider M2 the n number of event into such that S2 less than X and then less than or S2 causal difference on X, S2 causal difference on X and then X causal difference on R2 holds for all messages EA. For EA send and receive event there exists some linear execution such the corresponding interval X belongs to E and S less than X less than R is also empty. This is a empty interval property. So another one common fast and features. Common fast and feature based on an execution capital E causal difference is causal order if for each pair S comma R belongs to T and each event E belongs to capital E means so V common fast E causal difference are E causal difference on R belongs to S causal difference on E and then V common feature is S less than E equal to E cancel element on depends on R. These are the concept of distributed computations, communications of message ordering. In that we have algorithm of message ordering, the Baghdadi algorithms. So receive commands are enabled for all processes in the interconnection of networks computers. We have n number of process. So each and every process want to communicate means it send the permissions. After getting the permissions, it send the events. First one, in the Baghdadi algorithm, receive commands are enabled for all process. Initially, all process enable the receive commands. Send command is enabled is in active until it gets complete. Send command enabled is in active until it gets completes. To prevent deadlock, asymmetry break method is introduced in the crown ice. Each process attempt to send only one send event at a only send event at a time. That's called as a Baghdadi algorithm. Okay, so thank you.